A very good day to our lecturer, Dr. Saiful, and to my group member. Today, we'll be doing a presentation on the simulation of two circuits, which are emitter bias circuit and clamper circuit. Before that, let us introduce ourselves. My name is AUTREBERTA Augustine, and my group member are Nik ALIA ABRISYAH binti Nikmat and NURUL Hanan Khaziman. For our first simulation, we had constructed an emitter bias circuit based on the design that we had calculated and drawn from the assignment. The configuration of emitter bias is used to bias a BJT transistor in order to activate the transistor and prevent it to either to the saturation mode or cutoff mode as to provide the stability of the operating point in BJT characteristic. Although the emitter bias circuit is added with the emitter resistor to the emitter of the BJT transistor, but based on the calculation, it is not used. Hence, we will only apply collector resistor, base resistor, and two DC source that is connected separately at each terminal. Next, ALIA will explain further on this emitter bias circuit.
Okay, I'm going to explain in detail about circuit in question 1. Okay, firstly, we have two DC battery. The value of this DC battery is 19.25 volt. Why? Because this is the value that we get in our assignment question. So, secondly, this RB, this resistor is 620 kilo ohm. This is the standard value for this resistor. In our assignment, we get around 613.33 kilo ohm, but the standard value for it is 620 kilo ohm. So we use this one, and this one is RC. The value for RC is 2.4 kilo ohm, and the transistor we use NPN transistor. The beta value is 133.333 beta. Okay, this is the full circuit for question 1. Then we need to add the probe. Okay, we use the voltage and current probe. We need to put it here first. This probe is to calculate the value for voltage and current from the base, and then this is the second probe. This probe is to just confirm that we use 19.25 volt, and then the second probe, this is for the value of C terminal punya, and the second probe, the fourth probe here. So that is the so that all the probe that we use. Okay, for probe, and then you just have to run the simulation. And here it is, the value of voltage and current after we run the simulation. So we get exactly as we calculate in the assignment.
Assalamualaikum and hi, my name is NURUL Hanan, and I'm gonna explain and show the simulation circuit for question 2. Question 2 is about the clamper circuit. Before we start, I'm gonna emphasize that for question 2, the voltage input is in square waveform, but due to the limited sources here, we're gonna use AC sinusoidal input instead. So instead of square waveform, the input and the output will be in the sinusoidal waveform. Okay. For the capacitor and the resistor is choose based on the formula tau, which is tau equals to resistor times with capacitor, because it must be large, tau must be large to ensure that it doesn't discharge during the interval that the diode is non-conducting. So the capacitor value is 1 microfarad and for resistor is 100 kilo ohm. Okay, for another source, which is battery here is 2 volt, and the diode here is a silicon diode. Okay. Okay, this circuit design here is actually designed based on the question 2 from the assignment, and we're gonna simulate and see if the output is similar to the calculation result. Before that, we're gonna put to simulate this circuit. We're gonna put the probe here for V in and another probe here as V out. Okay, so now let's simulate and see if the value is similar to the calculation result. So for the green one is V in and the blue one, the blue color is V out. We're gonna take a look at the voltage peak, which is the maximum value, the positive maximum value, and the peak over here is the maximum, the minimum value. For V in at 9.97, the V out is 2.5765, and when V in is at -10, -9.97, the V out is at -17.37. So based on the calculation result, for V out at maximum point, the value is 2.7 volt, and based on the simulation, it is 2.57. For the minimum value is -17.3, and based on our simulation, it is -17.36. So my conclusion is the value from calculated result and our simulation result is actually quite similar. So that's all from me. Thank you.